G'day guys, welcome back. I've got another math puzzle for you. Now this one's going to be a little bit more abstract to my other puzzles. Usually I try and make them somewhat practical. Here there's no connection to reality whatsoever, but nonetheless, I think it's a good one. Let's give it a shot. What is a function, f of x, such that this is true? So if I were to give you a value of x, say 1, I need you to invent a function f of x which pops out 1. And if I give you a value of 2, that function needs to pop out a value of 1. And if I give you an x value of 3, that function needs to pop out a value of 3, etc., etc. And you can see the pattern here, okay? Now, in case you're a little bit unfamiliar on what does a function really mean, I basically mean come up with an equation. So like, for example, you can come up with the equation x squared, such that if I were to give you the value of x equals 1, x squared will give me a value of 1. And if I were to give you a value of 2, x squared would give me a value of 4. Uh-oh, x squared doesn't work, okay, right? I need you to come up with an equation, basically, which pops out these values for these values of x, okay? Well, the problem has been stated. Have a shot. Come back when you're done. Okay, well, I think the first thing we need to notice about this relationship is for every odd number of x, we need our function to pop out that same number. And with every even value of x, we need our function to pop up that same number minus 1. Notice that's always going to be true. So let's write that in the form of an if statement. We can say if x is odd, then we need our function to become x, right? That's basically describing every odd number here. But if x is even, then we want our function to return a value of x minus 1. So somehow we need to compress this into an equation. Somehow we need to compress this simple if statement into some type of equation, right? And let me get you started. We're going to say, and this is one way to do it, we're going to say f of x is going to be equal to our value of x minus something here, which will spit out 0 if x is odd, or 1 if x is even. So we need to come up with something in here which can do that. And when I first attempted this problem, the first thing which came to my head instantly was the cosine wave. So let's consider this. And I know it seems super disconnected, but bear with me, you'll see how it's connected shortly. Let's consider the cosine wave just here. It's very repetitive, like this. It just goes up and down like this. And of course, it's got this part here would correspond to x equals pi on 2. This will be pi. This will be 3 pi on 2. This will be 2 pi, etc. But what we can do is we can compress this cosine wave such that it has a root here of 1. This right here would be 2. This right here would be 3. This right here would be 4. And we can do that by writing this. This is going to be the equation y equals cosine of x times pi on 2. Now, prove it for yourself that this is true. Plug in x equals 1, and you're going to get cosine of pi on 2, which is 0, it works out. This right here, this equation describes this looking graph, okay? And this is actually pretty good. It's really close to what we want, because notice for all odd numbers, and let me draw this extra 5 in here, for all odd numbers, this function returns 0, which is great. That's exactly what we want. But for all even numbers, it kind of alternates between returning minus 1 or plus 1, or minus 1 or plus 1, or minus 1 or plus 1. And we need to fix that somehow. That's not good enough. So what we're going to do, or at least what you can do, is you can choose, okay, well, we can absolute value this thing. Or if you like, what I prefer is squaring this whole thing to force these negative values to become positive. And let me kind of draw that graph right underneath here. So I'm going to try and keep it in line. This is going to be the graph y equals cosine pi on 2x squared, right? And it's going to look like this. It's going to look something like this. I hope I can keep that in line. It's not very easy. There we go, okay? And we'll notice that these parts where it hits the x-axis is going to be all odd numbers, 1, 3, 5, 7, etc., etc., and the points which correspond to a value of 1 will be our even values. This will be 2, this will be 4, this will be 6, etc., etc. Okay? So we've got a function now y equals cosine pi on 2x squared, which spits out 0 for odd numbers and 1 for even numbers. That's perfect. That's exactly what we're looking for. So we can just write this in here, and we can write this as cosine pi on 2x squared, right? And if you don't believe me that this will work, try it for yourself for a few points. What happens to our function f as x is equal to 1? Well, f of 1 is going to be equal to 1 minus 0. It works out. What about f of 2? That's going to be equal to 2 minus 1. It works out. Everything works. And you can try this for a billion values in Excel if you like. I promise you it'll work out just fine. So this is one possible function. This is one possible function that will get us the values that we need. Now, there are countless. There are probably hundreds or thousands of different functions which can do this. I've just shown you one of them. Another clever function could have involved using minus 1 to the power of x, if you were brave enough to try and go down this route. It's really up to you. Now, in case this video was a little bit too easy for you and you're looking for a much harder challenge, I've got an additional puzzle for you. So let's consider a new function. I want you to find a new function, g of x, which returns these values. 1, 1, 1, 4, 4, 4, 7, 7, 7, and then 8, 8, 8, etc., etc. This is a much harder problem. If you're keen for a challenge, go ahead and try it. Okay, I'm gonna write the answer down for you right now. There we go, guys. That is one function, g of x, which will actually satisfy these values just here. I'm sure there are many other ones, but this was a much harder problem to solve. Okay, guys, I hope that was enlightening, and I hope you really enjoyed that video. Just so you know, I also do a whole bunch of videos in engineering dynamics, vibrations, and statics, so check them out on my website too if you like. Cheers.